we're going to be working with the cosine sum and difference identity. If you want to follow along, the links to the companion worksheet are in the description below. Also, don't forget to click that subscribe button so you can stay up to date on all the videos we have coming out from the channel. So let's get started. Now, the idea of the sum difference identity, one of their applications is that if we want to figure out an angle that isn't on the unit circle, we can say, wait a minute, we can't find negative 15 on the unit circle, but there are angles that we can add or subtract to get us there. So how do we get to negative 15? Well, there's a bunch of ways. And the way that I'll use is 30 degrees minus 45 degrees. And so up here, what we have is our identity. And so A is the first angle and B is the second angle. And so what this says is you take cosine of the first angle, which is 30 degrees, and cosine of the second angle, which is 45 degrees. Now the big thing to notice is that this says plus or minus, and this says minus plus. And the idea is that if you're subtracting the angles, then you're going to add these two quantities out here. And so then we take sine of the second angle, which is 45 degrees, times sine of the first angle, which is 30 degrees. And actually, since you're multiplying, it doesn't really matter what order you multiply them in. Now, all of these we can find on the unit circle. And so the link to that is attached down below in the descriptions. So, what is cosine of 30? That is square root of 3 over 2. What is cosine of 45? Square root of 2 over 2. And then we'll add sine of 45, which is square root of 2 over 2, and sine of 30, which is 1/2. All right, so we're multiplying fractions. So square root of 3 times square root of 2 is square root of 6 over 2 times 2, which is 4. Square root of 2 times 1 is square root of 2 over 2 times 2, which is 4. So the answer we get is on the top, square root of 6 plus square root of 2 all over 4. All right. So with number 2, here we want to find secant of 75 degrees. Now, we don't have a sum difference identity for secant, but what we recognize is that secant is the reciprocal of cosine. So we can find what cosine of 75 degrees is, and then from there, we can figure out what is secant of that. So how do we get 75? Well, we can just do what we did up above, except add the two angles. Take cosine of 30 degrees and add 45 degrees. So according to the identity, we're going to take cosine of 30 degrees times cosine of 45 degrees. Now here we're adding, which means we're going to subtract here. Sine of 30 degrees times sine of 45 degrees. All right. Now, if you notice, the setup is almost identical to what we had up here. The only difference is we are subtracting instead of adding. So to save ourselves a little bit of work, because if you've done the work once, there's no real point in doing it a second time, it's going to be, this quantity is going to equal square root of 6 over 4. We saw that. And this is going to be square root of 2 over 4. So when we subtract them, we get square root of 6 minus square root of 2 all over 4. That should be a 4. Now this again is equal to cosine of 75 degrees. What we want is secant of 75 degrees. So if we take secant of 75 degrees, that's just the reciprocal. So that's going to be 4 over radical 6 minus radical 2. Now, if the directions or your teacher wants you to rationalize this denominator, we can do that. What we do is we multiply by square root of 6 plus square root of 2 over square root of 6 plus square root of 2. So when we do that, we get 4 radical 6 plus 4 radical 2 all over. Now this is a difference of squares. So we're going to get 6 plus radical 12 minus radical 12 minus 2. So that means we're left with 4 radical 6 minus 4 radical 2 all over. The radical 12s down below cancel, and so we're left with 6 minus 2, which is 4. So that means we can cancel the 4's here, and therefore we're left with simply radical 6 minus radical 2. And so that's the value of secant of 75 degrees. Now, number 3 is a different type of problem, because we want to find the value of cosine of x plus y, but they don't tell us what those angles are. All they tell us is what is cosecant of x and what is cosine of y. And they tell us that x is in the 4th quadrant because it's between 3 pi over 2 and 2 pi, and y is in the 1st quadrant because it's between 0 and pi over 2. So what we do is draw ourselves a little picture. So up here is angle x. Now what do we know? Cosecant is negative 5 over 3. Well, that means sine of x equals negative 3/5. So in this picture, this side is going to be negative 3, this side is going to be 5. And so using Pythagorean theorem, the adjacent side should have a length of 4. Now, for y, we're told that that is in the 1st quadrant. And we're told that cosine is 12 over 13. So that means the adjacent side is 12, and the hypotenuse is 13. So that means the opposite side should be 5. Now, I'm going to set that aside for a moment, but we'll revisit that really quick. Now, if we want cosine of x plus y, now if we apply the identity, what we get is cosine of x times cosine of y minus, because remember, we're adding this, so we subtract, minus sine of x times sine of y. Now, cosine of x, what is that? Well, you look up here at this picture and we say the adjacent side is 4 and the hypotenuse is 5. So we get 4/5 for cosine of x. For cosine of y, well, we were told that. That's 12 over 13. And we're multiplying those. Now for sine of x, the opposite side is negative 3. The hypotenuse is 5. So you have negative 3/5 times sine of y is 5, the opposite side, over 13. All right. So now we multiply these. So we get 48 over 65 minus, let's see, negative 15 over 65. So that means we get a value of 63 over 65. And so we were able to figure out the cosine of this angle even without ever figuring out what is the actual angle of x or the actual angle of y. All right. Now for the last one, it says we want to prove this identity. Now this is true to begin with. It's an odd-even identity. And what it says is if you plug in a negative angle, it's equal to cosine of the positive angle. Now how do we prove that using what we know is the sum difference identity? Here's how we do it. Here we have negative x. Now we could think of this as 0 minus x. And so according to the identity, that's going to be cosine of 0 times cosine of x. Plus, remember that we are subtracting here, so we add here. Sine of 0 times sine of x. Now x, we don't know the angle, so therefore we can't know what sine or cosine is for that. But we can go to our unit circle and ask, well, what is cosine of 0 and what is sine of 0? Well, cosine of 0 is 1. And sine of 0 is 0. So therefore, this whole term disappears, and so we are simply left with cosine of x. So What this shows is that if we apply the sum difference identity, we treat this as 0 minus x, this quantity is equal to cosine of x. So we have verified that identity. Thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.